Many of you know Lambdas. It's pretty good. And AWS services in general? Even more. Okay, good. So let's start. What is Lambda? That's a quote from their website, that Lambda lets you run the code without provisioning or managing the servers. And another sentence is just virtually you can run anything on Lambdas, which is not really true. Like, you still need to do some provisioning to get it running, so it's not easy, but most of it's done for you. And for JavaScript, they have two versions available. V6 is still available, but it's deprecated. It took a while for them to do it. I think V10 is only in May this year was introduced. Let's start with money, so you know if it's worth it or not. So they give you 1 million requests for free, and after that you pay 20 cents for each million, which is cheap. And this is new measurement probably for most. You get 400,000 gigabyte seconds for free. And one thing, this is free tier, and for Lambdas, they don't expire free tier. So after a year, after 2 years, after 3 years, you still get that part for free. It's not as other services like EC2 and everything, you get it only for 12 months. So as an example, if you need Lambda with 256 megs, that's 1.6 million seconds of runtime for free. And as you go more with memory, you just pay more, so you get less seconds, but you can do more stuff. And the billing is based on 100 milliseconds, and it's rounded up. So for 101, you're paying 200. But it's a good thing if you want to be super, scrappy and do as much stuff as you can check the timing. They provide the API, so you can check if you're, for example, on one-on-one, oh, maybe I will do some Bitcoin mining. You could. Actually, that could cost you a bit more, but still, because that's a lot of money. When you run the reports, you usually end up something just a bit over. So to run it, what at minimal you need IAM role. So that's the one thing that is not provisioned for you. Unless you use the AWS console, they will do. So you just need to provide handler name. That's basically the name on module exports, what you're exporting from your module, and just write some cool JavaScript. And optionally, you set the memory limit. So default is 1 gigabyte and maximum 3 gigabytes, and it's in 64 megabyte incrementals. Fun fact, they recently updated their console UI. The slider actually steps through 64 megs. Before, it was whatever. So if you set 65, you are charged for 128. So you still need to be careful when you're using other tools to provision all that stuff, because in your code, you can input whatever you want. So you still can provide 65, 66, or whatever. So you need to be careful, because you're just wasting money. And timeout, because if you know that your Lambda, after 3 seconds, truly dead or somewhere in an infinite loop, you set it to 3 seconds, because default is 30 seconds, and that's basically 10 times more wasted time. Time is money in Lambdas too. And VPC. So VPC, you will need VPC if you will want to interact with your own other services in AWS, but it adds you 8 seconds for the cold start. So if you have a request, 8 seconds dead, just because you're Lambda in VPC. But there is a good thing. This in September 3rd, they made an update for VPCs, So it's actually can be shared. So if you have one instance of Lambda running and another request comes in and it creates the second one, it's, I don't remember exact seconds, but it's not 8 seconds anymore. Like it's super fast compared to previously, because previously it would create another elastic network interface for each Lambda instance. Now it's shared across all of them. And layers. Layers is a pretty recent too. I think it's just last year they announced that you can, it's a Lambda code and you can have like a layer where you can upload like a, most likely it's usable for shared code. So if you want to upload the, I know, node modules, some more packages, your deploys will be faster because you don't need to deploy every single time, like let's say 2 megs of Lambdas, and you just deploy 100 kilobytes. So provisioning and publishing tools. You can use just command line tools and the console web UI. So in AWS console, the role will be created for you, like the dummy one, like empty. CLI doesn't do that for you. The same Amplify is a AWS framework. It just basically wraps many AWS services to make your life easier. It can provision like the Cognito pools, like for authentication. The same Lambda execution is much easier. You just have simple API, and it can publish the Lambdas for you too. And serverless. This is my most favorite. At least I found it easiest to work with. And there are probably many more I don't know even about. It's JavaScript. Every single day, new framework is born. So one important thing, keep an eye on your versions, because every time you edit, upload new, like update the code, it creates, AWS creates new version for you. So you always have older versions, but in most cases, you don't use old versions, and it just piles up because your account has 75 gigabytes of storage limit. So with JavaScript, usually it's not a problem. Python code is a bit bigger, so we run into a problem pretty like after a few years. But with JavaScript, it's fine because in general, the packages are smaller. So just keep an eye there. For example, for serverless, there are plenty of plugins that you can set, like keep only last 2 versions, which is enough. So we love the console outputs. Where do we find them? So to get that, you will need to give 2 permissions. One is to create and another put log. Put log events is the most critical one. Like create, you can create the log stream manually, but I don't recommend to do that because it's better automatically. And there's a AWS service, I would say, CloudWatch logs. So you just go there. You need to get used to it. It's a pain to use. Like it's not straightforward, but another thing, you can reserve or not reserve concurrency. So what it gives you, by reserving, you guard your scaling of your Lambda because you have a limit per account, per region, 1,000 instances at the same time. So if your account is busy in that region, your Lambda just won't scale up. So by reserving, you making sure that this specific Lambda has 20 instances as a maximum. And at the same time, it says the limit how far you can go. So if you want to limit for some reasons that you, I don't know, maybe not to spend too much or something, you basically limit so it won't scale up crazy to 1,000 not request instances. So at the same time, we can talk about bursting and scaling. So the first is it's a 1 instance, and each, like a small block, let's pretend it's a 1 second of execution, and every single green block is a separate request execution. So in this case, once one execution ends and another comes in, it's pretty simple. AWS will reuse the same instance and will just run all of them. But if we get more of them, for example, now the first one is still running, and another request comes in, so it creates another instance. So now we are at 2 instances. It runs, the third comes in, and 4, so it starts 4, and so on. So the bursting is a bit different because the scaling is how much you can have for a long period. The bursting is for short time loads. So if you have like a 500 requests in 1 second, it just will help you to deal with it. I will talk about it later. There are very different limits for different zones. So, and there's people start using the hot and cold Lambda, like naming. So the hot one, that it's still alive, like after execution, AWS still keeps it somewhere in a frozen state, so it's ready. So we don't get those 8 seconds cold starts or whatever. And the cold, when there was no instance, so the request came in, it created VM firecracker, as they call it. They open sourced it last fall, I think. So just a basic examples how you can define the JavaScript for the Lambda. So as I said before, you just export some function, and after that in your Lambda settings you define what function AWS needs to find. So it can be async with the callback, or if you don't provide callback, it will be synchronous. But from version 8, you can just use async await to make your life easier. So one of the interesting parts for me, it was the event loop. So this just as a reminder how it works in Node. So it's a simplified one, so we don't have API threads and everything. So basically we have a call stack, we have task queue that it's filled up from the APIs. So by default, your Lambda execution ends only after event loop is empty. So if you returned something earlier in the middle, your Lambda still executes. So basically your client already, or like already got the data, everything is fine, but it still executes. So basically you still pay money for it. But and sometimes you might want to do it, so you are responsive, and if you don't change the response code or the response itself, even if something fails down the road, you want to be quick and do the diligence, like doing something in the background. So for example, simple code that is one main function that spits out main in the standard output and calls another function worker. So our stack would look like that. We have main, after that it goes to console, finishes executing, goes back, and after that goes to worker, and after that it calls the console log, and after that it just finishes the work. So since I told you that it's still executing stuff, how you can reuse the connections to database and everything to make your Lambdas faster so you spend less money on your backend stuff. One thing, if you will add MySQL, Postgres, Redis connection to your Lambda, you always will get Lambda timeouts, because even if request came in, you did the business logic, send the response back, your connection on all the background stuff in the event loop will keep it running. So after that, AWS will kill it after 30 seconds. So basically, you're paying much more. So you either need to choose not to reuse the connections or pay more and still be penalized, because next time you will need to reconnect again. So this is about the default behavior, so I jumped the gun before. But you can change this behavior. There's a long property that you can flip to false. So in that case, whenever you return something as a result, it freezes. It's a term. It's a frozen freezes. gotchas with that if you don't handle your code well, there might be stuff not finished after you return the result. So if you're not handling your promises, or you're not looking if it's finished or not, you just fire the promises blindly, just go raise, do whatever, and you finish, that will be frozen. So, and it will be executed again once another request comes in to the same instance. So it's better just handle it better, not it better, but properly. And for the connection persisting stuff, it's better if the library itself can handle implicit reconnect. So if for some reason you lost the connection, it just reconnects for you. So you don't need to like subscribe to events and do it before you actually make a request. You make a request, if there is no connection, it reconnects for you and gets you whatever you wanted. So at least your code is much simpler. So this one example, as you see, the callback is in the middle. In this case, it's a super simple synchronous code, but just let's pretend it was async stuff. So in our case, once we go to callback, oh, it covers everything. So I'm not sure it's very visible, the freezing line in the middle. So that's where the Lambda execution would stop in this case. And if this hot, while it's hot, Lambda would get another request after that, it would finish execution, and after that would start over again. So basically you start overlapping the executions. But if it doesn't get request in, I know it depends on the zones in AWS and regions, and even how much memory you assign to Lambda, that hot and cold time is very different. So there is no guarantee, and you can't check if it's hot or cold. So basically you might lose the execution if it just closes it. Another interesting feature that, for example, if you use like Amplify to execute your Lambdas from the browser, it will try to retry if it's not bad request. And what's interesting, it's the same if you're using like step functions, like all internal tools in AWS, not services, that will fire off the Lambda. It will try to retry, but the most bizarre thing, it will use the same request ID, like internal AWS request ID. So if you're looking at the logs and you're trying to understand what the hell happened, you will see the same request ID. So before if you don't know it, it kind of can make you go crazy, like because you don't understand why it's executing twice with the same thing, or why you have the same outputs. But once you know it, you know that probably it failed before. So for use cases, we can use it for website, APIs, single page application, backend, and mobile apps, IoT, file processing. This is plenty used for S3 stuff. Once you upload, because you can trigger, once you upload or change the file, you trigger the Lambda that just spit out some kind of reduced file version. Step functions is a really nice feature because you can have like a year, I think that the maximum is a year span workflow. So you can have like a web of steps, what will happen, and they don't need to be like, it's all Lambdas, or it can be other service, it can be that user approves something, and after that it trickles down. But this is another story. It's a new presentation on its own. So about the limitations. So that's 1,000 instances per account per region, but you can ask for more. I don't know what's the maximum you can ask. So 75 gigabytes of storage. And something you can change. So the longest runtime is 15 minutes. So if you're using Lambdas to generate reporting or something, you need to fit in that time, or make it so it kind of partially does the things and leaves for the second, like follow-up request. The payload, that's different. So if you invoke, and it's not how you wrote the code, like async or synchronous, it's how you invoke the Lambda. Depends how big the payload can be. So if it's async, it's pretty small, but async, I didn't remember now exactly, bursting is not limited or something. So it has some benefits to go async, because I don't want to lie now, but there are benefits going async. So, but burst limits, those are very different burst limits for every different regions. And there's more. And once you start playing around with more services, other limits come in, because, for example, the policy, not the payload, the policy size is 20 kilobytes. So if you have a policy that this Lambda can be evoked by CloudWatch multiple logs, your policy size grows like super fast. So you need to be more careful how you define the policies, because you can have like a wildcard. So if you have like a service name and after that Lambda name, so you can give the permission to all service instead of every single Lambda. Questions? I tried to be fast because I wasn't sure I will fit in time.
With the concurrency limits, if you end up exceeding those, is there like a queue that like?
No. You will get, I think, 4 to 9 response if it's like a API gateway driven request. Okay. But it will fail. Like it won't queue somewhere. I think async does those things, but I remember. We didn't use async just because the payloads were just too small for our case.
Does the concurrency limit, is that 500 in Canada for Lambdas? Because there was other regions I didn't see in Canadian.
Yeah. So it's for bursting, it's per minute.
Yeah.
So you get 500 for 1 minute, and after that you can again get another 500. So you can go over 1,000, fine, but for a short period of time. So if you have, like if you're running like at 900 and you get like a load of another 700, so 200 will fail, 500 will succeed, but you can't reuse those bursted instances. Those will go away. That's the difference. If you scale, those will stay alive.
Have you looked at anything where you just decided that this type of server function was not practical to use with them?
If you start small, I would go with Lambdas now, because it's free. Like if you don't go like higher, and even if you go to bigger scale, it's still cheap. Like it's still not even close to EC2 instances. That most of the time they're doing nothing, just waiting for requests. Because if you go too busy, if you do like JavaScript, it's not straightforward to port everything to like EC2 instance, but you still could switch gears and stop using Lambdas. That's fine. But even the same for companies that do POCs, or even they start the business or something, and they don't know. Like they don't know how much they need to scale. So if they scale more, that's probably, it's bringing money for them. So they can pay for if they need to go higher at the scale. I would try to use it as much now, actually, because it's pretty easy. It's somewhat painless. I had more pain with EC2 instances than with Lambdas. And you can, especially with step functions, you can do crazy workflows and with ease. Yeah.
To start a new instance?
If you use VPC. If you don't, it's 4 or 5. It's only for VPC. So you have 12 seconds. If you use VPC, it's a 12 seconds if you had no instance.
So how do you avoid that for like a dynamic service that doesn't have a lot of
Yes, that's
usage, but when somebody's on your website, you don't want them waiting 10 seconds for that function?
yeah, that's one of the biggest cons if you really care about responsiveness. But you can poke it from time to time because there is on GitHub, there is a code base that one guy shared. You can run the tests and with different like memory settings and figure out in your region what is the time when it gets killed. So after that, you can back off, and just keep it hot if you want.
So
Yeah,
pay
it's
a little extra.
yeah, it's funny, right? But it's because it's different. The same like when EC2, you're paying and you see that it wasn't even used at 50%. Yeah.
How do lambdas play if you're trying to use like more of like a framework or structured data code, or is that like the wrong way of thinking when you're trying to architect something with lambdas?
It's pretty agnostic on the frameworks. It's more about what you're trying to solve. Because one thing that many frameworks, if they're intended to be running on a VM, so you don't get something like a shared memory that you could do so some things will be broken out of the gate. So you need to write code differently, basically. But you still can do everything same way. One thing what is good, the development gets a bit easier, like you totally separate the business concerns. This Lambda, this, that's it. It's over. It will share some library code with other Lambdas, but the business logic will be very isolated. So you don't mix some services or controllers like that. It's harder. It's funny, but in other cases, it makes it a bit easier in development. Like I think that's the best benefit having Lambdas. Because all the small ones, you don't overthink things.
It feels like command query separation, event sourcing, like some of those approaches probably lend themselves better.
Yes, and microservices are pretty easy with Lambdas. So AWS have SNS for messaging, so you can just do whatever you want. So for example, you get a request and you fire off the pipeline, you say start it, and whatever 5, 4, 10 Lambdas do the different things, and you don't really care, like how many of them. And after that, with step functions, you wait for all the results coming back, and after that, you say to customer, this is your result.
Is there quite a bit, are you able to pass reasonably large payloads like through each of those steps, or?
For step functions, it's a limit 32 kilobytes, but you have S3. Lambdas, when you're executing Lambdas, the traffic between Lambda and S3 is not accounted, so you don't pay for it. For the storage, you still pay, but the traffic doesn't, so you just use it as your storage. So you just basically pass the keys around.
So are there any frameworks that you do kind of recommend using with AWS Lambdas, or do you generally just write from scratch yourself?
Frameworks for what? Solving?
Like for handling, like working with the handler and stuff like that.
You just write your own because it's super simple. Yeah. You just small functions. That's the beauty. You just small functions. You don't think in frameworks.